Despite digital substations and AI hype, poor data quality is still slowing down engineering and inflating project risk.
This is Powering the Future, a podcast series brought to you by Smart Grid Forums. One planet, one power grid.
Joining me today is Nils Weber, co-founder and director at primtech North America. We'll chat about how structured substation data is becoming a competitive advantage for utilities. Hello, Nils. Welcome to the podcast. So pleased to have you with us today.
Thank you for having me.
So, Nils, we've had a really interesting discussion in the last few days about data quality. This is a big issue for the utility sector. It's been an issue for a long, long time. I know I've been talking to utilities about it for at least 15 years. And what I've noticed is that the situation isn't really improving. There are workarounds. Utilities are finding workarounds, but these are not permanent solutions. So, from your point of view, why do you think it's still a challenge, and what sort of solutions are on the horizon to help utilities resolve the big issue of data quality?
Yeah, good question. I think everybody knows somehow that data quality is an issue, but a big question actually is, what is data quality even? Right. Mm-hmm. So when you start thinking about it, you quickly realize that it actually depends on the use case. So what do you need the data quality for, and how good should it be? What is good enough, right? So when we talk about data quality, we need also to talk about a data quality metrics. So something that defines and measures the data quality for your actual use case to really get hands on that. So and especially when you look at the power industry, it is the grid is already existing, most of it, right? Or a lot of assets are already built. So the challenge that we have, especially in the electrical infrastructure, is that we have a huge amount of legacy data, and this data is old for decades. It is sometimes, hand-drawn stuff. It's files or content somewhere hidden in files and not really accessible for the organization. So I think one of the biggest challenges is how to extract this data, or how to get this data actually in the organization, and how to solve that problem of the legacy data. What we discovered is we need this, we call it a digital data inventory, so somehow a cleanup. So an effort wants to make data quality sufficient for your use cases. The solution for the data quality is at the end something like a digital twin. But a digital twin in the context of that are different data sources talking to each other, and different silos within the organization talking to each other, because data quality often becomes a problem when there are copies, and copy version 2, a copy version 3, somebody working on it and you're not aware of it. So how do you let these data silos and the data talk to each other so that a cleaned up process or cleaned up data is integrated into the company process? And this will help eventually that it's always synchronized with how the project, for example, progresses.
And I know that you're utilizing AI quite a bit to help improve the data quality. When we talk about AI, people have some concerns around it, and actually sometimes they talk about AI corrupting the data. So how are you using it to make it a lot more high quality and more efficient?
Yeah, it's a good point. You pointed out that we learned in the past years what beautiful things AI can do, but we've also learned what a mess it can actually produce, right? But the key for making AI shine is having a human in the loop, right? So then when AI is producing something, you need an expert to validate it. You need an expert to say, this is good, this is not good, and you approve things. So what we use AI for is, AI is perfect for comparing things, for handling huge data sets. And in our approach, we try to combine 4 single different data sources and combine them with the help of AI. That means that we have geometrical data from 3D point cloud scans. We compare that to data that has been taken from pictures from nameplates of actual devices. We combine that with asset management data. We combine that with single line diagrams. And AI tools help us to find the essence of what is correct. So when you have 4 independent sources, and you have 4 times saying the same thing, you can be really sure that this is valid. So AI is helping us a lot to compare all these data sources to find out what is 99.99% valid. That's the first part where we use it a lot. The other is, of course, that when you think about rebuilding existing assets. AI is helping us by trained neural networks for data creation, so that when we have point clouds, neural networks can help us to create devices, transformers, and rebuild the actual substations based on the data that we collected.
Right, okay. And this is really helping you boost design efficiency, isn't it? Tell us a bit more about that.
Yeah, especially in this process where you digitalize the existing data. We have seen people doing or trying that for decades. They have tested that, and the first project we did 10 years ago, the first reference was a company who needed 6 months for a single substation to be digitalized. And that is not applicable if you have hundreds of substations and you need half a year for processing that, right? It's not providing the value that you need. And we have now come to a point where we can digitalize hundreds of substations within a year. So that means the transition time for a company is not a couple of years or a decade. It can be done within a year typically. And that's why this AI is so much specialized on substation, and therefore, providing this high efficiency of redesigning existing substations.
And is this being taken up by utilities at the moment, or is it a concept that's becoming ready for market?
This is already happening for the past years. We're currently having here, we call it a digital twin factory. So we have here in our organization a couple of people, or a big team actually, being specialized on this process. So we have some guys are really experts in how transformers work. We have others who have expertise in how wire and tube connections work, for example, and they all play somehow together. But this is a well-established process, and we have companies who went through the complete grid now. So they said, I want to have data quality for my 200-300 substations, and that has been completed.
Right, okay. And so how are your solutions actually helping substation engineering teams improve their output from the point of view of actually building out the substations?
If you look at anybody who is doing a substation project, you have greenfield projects and you have brownfield projects, right? And especially brownfield projects mean that you add something to an existing station, that you want to have a refurbishment, that you add components and so on. And if you look at the data quality that we provide, for example, is eliminating completely the project preparation time. Sometimes it needs weeks for just kicking off a project, or worst case, you start a project with wrong assumptions. So every project starts usually with, I go on site, I check it out, and then I start my work. So by eliminating this data capturing or setting the foundation for the project, this is already a big booster for brownfield projects. And when we talk about greenfield projects, our software is for now 25 years highly specialized in designing new assets. And the big idea here from us as a company is, even though the utilities and the electrical infrastructures spread around the globe, we still have the same manufacturers providing the assets. So we have a Siemens, we have ABB Hitachi, we have GE, and all these big manufacturers, right? And what we do, for example, is we collect their offerings of equipments they provide and provide them in libraries, so that when somebody uses our software for building new assets, they have already everything they need. So they just need to click the pieces together, basically to do their substation design process. And next to that, having, of course, multiple design checkers, multiple tools of validating your model. So you're not only building a nice 3D model, you have tools that validate electrically your station. And that means that a process that was before somebody designing it, sending it to somebody to calculate it, sending it back for changing something, we basically shrink together. And while you're designing it, you're checking it. That means that the project delivery time is speed up at the end by the factor of 10.
Right, okay, that's quite impressive. So I guess you're working with a number of utilities in Europe at the moment, but there are many others who are yet to hear about your solutions and your expertise. So we're very pleased to have you at SGT26 at the end of March in Paris. What can utilities expect to see and hear from you at the conference?
Yeah, at the conference, we definitely try to explain the complete package of our offering, right? That starts from how do we digitalize your existing grid within 1 year? So how do we set the data foundation? Then we will talk about how to use this data in brownfield projects, and we will talk about how to use primtech 3D in greenfield projects and how this speeds up your engineering time a lot, and especially the communication with contractors and suppliers. Instead of handing over files and documents, they hand over data models, right? And this gives them a huge transparency in their actual projects. We will talk about how to integrate our data models into the ecosystem of utility. And this becomes important. We talked about data quality, right? This becomes important when you want to bring these silos in an organization together and give you a full perspective and a full picture of your data. So we will talk about how we integrate our data. And lastly, our latest baby, and you maybe see it here behind me, it's our VR access to the substation design, engineering data, and to the digital twin data. So it's a very natural way how you can consume data. You don't need any training for it. You just look at an object, you get all the information you want. You can see the current flow in there. You can switch that station. So we not just want to have the data in our silo, we really want to give it to everybody who's interested in that.
Right, okay, fantastic. Well, we're looking forward to seeing you and the primtech team on site at SGT26 in Paris at the end of March. Thank you so much for joining us today, Nils, and for your insights. Really appreciate it.
All right, thanks for having me. Have a good day.
Join us again next time as we unpack another big topic shaping the future of the power grid. Don't forget to subscribe to our YouTube channel, Smart Grid Forums, and to follow us on LinkedIn. Until then, thanks for watching and listening.
This is Powering the Future, a podcast series brought to you by Smart Grid Forums. One planet, one power grid.